Alright, so this is where everything kind of comes together and we finally get to start solving equations like the ones I referenced earlier in the chapter. This is actually the exact problem that we came across in an earlier video that I showed you guys we couldn't get the exact answer for. Today we get to figure out how we do it. This involves that fourth property that we learned, the third property we learned in our last video here. The big thing is, when we have logs on when we have a log in a problem, we're allowed to drag exponents out from the exponent out front of the problem. So what I'm going to do on this problem right here, just like I can do stuff to whatever I want to both sides of an equation, I can add 7 to both sides, divide both sides by 2, I'm going to take the log of both sides of the equation. So I put a log in front of this side and in front of this side. Once I do that, I'm going to use that property that I said was such a big deal here. And I'm going to take that x in my exponent and drag him out of the exponents, putting him out front. This is good. X thought he was untouchable up here in the exponent because we didn't have a good way to solve for that. But if we drag him out front, we know how to solve x times something. Now, log 3 is just a decimal. I don't know what it is off the top of my head, but it's a decimal that I can very easily type into the calculator. What I'm going to do right now is divide both sides by log 3. So, when I have this right here, remember our properties that we learned in the last video were for adding and subtracting logs. We don't have a property for dividing two logs, but we don't need one. All we're going to do is bust out our calculator right here, and I'm going to do log 12 divided by log 3. When I do that, I get the following answer here. It's 2.26 blah blah blah. Let me write that down. So x is about 2.26. And just to prove to you guys that what we did worked, I'm going to take 3, because that was my original problem here, and I'm going to raise it to that power. And when I do that, you see that you do, in fact, get exactly 12 on the dots. So it works out. So this is kind of a big deal here, and it allows us to solve for equations where our variable is in the exponents. On my next one here, you need to get the piece with the exponent by itself first. So we subtract 4, kind of like we're used to. We get 7 to the x equals 802. We're going to take the log of both sides because it will allow us to drag that exponent down. Oops. And we do that. We get x times log 7 equals log 802. And now what I need to do is divide both sides by log 7. So I need to do log 802 divided by log 7. And when I actually do type that into my calculator here, I'm going to get 3.43 and the decimal keeps on going. So x is approximately 3.43 for our answer here. We're going to do 2 more in this video just to make sure we've got this concept down. The problems can continue to get a little tougher looking, but it really doesn't change how things operate here. You've got to isolate the guy with the exponent here. So we need to add 18 and then divide by 5. So I'm going to actually skip the steps on that on the whiteboard here. I'm just going to do 3,000 plus 18. Then I'm going to divide both sides by 5. I end up with 2 to the x power equals 603.6. So I added 18, then I divided by 5. I am not allowed to do 5 times 2 right here, so you could not make this a 10. This part has an exponent, this part doesn't, so you don't combine those. You add, and then you divide. Taking the log of both sides and then dividing by log 2, I'm going to have to do log of 603.6 divided by log of 2, and that's just a matter of some button pushing here. If I actually type that in the calculator, it appears that we're looking at about 9.23 for x here. Our final problem is a bit more challenging because there are variables on both sides of the problem here. That's a little unfortunate, but our thought process and our way of going about things doesn't change. We're going to take the log of both sides right now, and then we're going to drag our exponents down out front. When you drag down an exponent that's not just a variable by itself, you put it in parentheses. So we're really looking at x plus 4 times log 17 equals 2x minus 3 times log 300. A little messy looking here. Now what I'm going to do at this point is decide, okay, I either have to divide both sides by log 17 or divide both sides by log 300 to make them go away. It really doesn't matter what you end up doing here. I guess I'll just divide both sides by log 17. And for the simplicity's sake here, because the numbers will get a little nasty if I don't, I'm going to round my decimal. So on this side, the log 17s cancel. This side is fine. I just get x plus 4. Over here, I still have my 2x minus 3, and I have to do log 300 divided by log 17. This is not going to be a pleasant answer here, so I'm just going to round it and accept the fact that my answer is going to be a tiny bit off at the end due to rounding, but I'm going to get pretty close. When I did that, I got about 2.013. So what I'm going to do here, that 2.013 is still outside of that parenthesis. I divided these numbers, I got that. What I need to do now is distribute this in. And really, this is making my problem a little less pleasant because I'm getting some nasty numbers along the way. But I have to distribute 2.013 blah 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 times 2. It's always good to use the actual number if you can. I get about 4.026 x. And then I need to do that same number times negative 3. And if I do that, I'm looking at negative 6.0395 blah blah blah. Round that to minus 6.0396. And while this looks complicated, I divided here, I had to distribute because I had a whole thing going on. This is just algebra 1. This is just solving for x. So what I'm going to do is add this 6 point whatever to both sides and subtract an x from both sides and just doing algebra really. Let's see. If I do that calculation, what I will end up with on my next step is 10.0396-ish equals 3.026x, and if I divide that, I end up with approximately x equals 3.317. Along the way, my decimals, I took a conscious decision. By adding decimals in this problem, I made my answer a little bit rounded in the end, but this is the approximate answer.